Hello guys, this is Krishna Jeffrey and now I'm gonna explain more about sets relation and functions. Sets basics of maths. Now we are going to learn this. Sets. First we should know about sets. What are sets? Everybody knows that set is defined as well-defined collection of objects. Set is well-defined collection of objects. Set is a well-defined collection of objects. Here, the word that should be keenly observed is well-defined. This way, well-defined. Uh, why to only observe well-defined is? We'll get to know that. Now, let us take an example. Uh, Set of favorite cricketers of you. Here, the word favorite. This is adjective. That means if there is an adjective which is describing something, then it is not well defined. Here, favorite means that's according to one's perspective, but the set is well defined for everyone. Like if you take some collection of objects, it should be same everywhere and same for everyone. It should not change for anyone. It should not be distinct. It should be the same. But here, when we observe suppose my favorite player is MS Dhoni. My favorite player is Virat Kohli. Some will have Virat Kohli, some will have MS Dhoni. Others will have Rohit Sharma, for example. So the word favorite makes ambiguity here. Ambiguity. We can learn ambiguity, which means difference. Here, now ambiguity. We learn that set of natural numbers. For suppose set of natural numbers. This is well-defined collection of objects because it's called as a set because natural numbers are perfectly defined, that is from 1 to and so on to infinity. But here the set is very well defined. Here the collection of natural numbers is a defined one. So this collection is called a set. So this is about the sets basics. And now set can be represented in two forms. First one is roster form, and the second one is set builder form. These are the two types how set can be represented. Let's learn these first. Now roster form. I'll give you a quick revision so that we will be completing most of the topics. Roster form. Roster form is here elements are being separated by commas and are enclosed within the braces. These are called flower braces or flower brackets. Now elements are being separated by commas here. Suppose 1, 2, 3. Let's write here perfectly. 1, 2, 3. Let's take a B, etc. Here it is a set of some 5 elements. Here elements are being separated by commas and are enclosed within these flower brackets. Here one belongs to this set. Suppose let's say A is equal to some, this is equal to some set A. This is defined by set A. Then 1 belongs to A, 2 belongs to A, but 4 does not belongs to A because 4 is not an element in this set. So this is how roster form is represented. This is how a roster form is represented. Now let us learn about some examples of roster form. Also we will be discussing two properties of roster form. First one, order does not matter. In roster form, order does not matter. Also, all elements present in this roster form should be distinct. Distinct means different, unique. So these are the two properties of roster form. And now let us discuss about some examples. Uh, let's say SCHL. This is nothing but LOHCS. Here what I am trying to convey is in roster form, elements order is not at all important. Here see, these two sets are equal. There is no change in the sets. This is nothing but this. Only the change here is order. So order does not matter in roster form. Here SCHOL, here LOHCS. Every element present in this is also present in this. So uh, this is equal to this. This is nothing but this. Also, let us talk about second property with an example. What is second property that we thought? Repetition of sets. Repetition. There is no element that should be repeated in roster form. Let's suppose apple. Let's take apple. APPLE. In apple, P is repeated two times, so we written it two times. But this is the wrong way where to represent a set. The right way is A P L E. No matter how many times an element is repeated, if the element is present in that word, only one time it should be written in this word. Likewise here. So repetition shouldn't be there in the case of roster form. Now let us talk about set builder form. In set builder form, we'll write down a property or some rule which gives us all the element of the set. That is, for example, A is equal to which for any set it should be enclosed between two braces, that is flower brackets. Suppose let us take x such that, here such that can be written like this or like this. I'll write both examples for you. X such that x is some natural number. Here we write down a property inside the brackets. That is, this is the property or rule that we are assigning to the value of x. We are assigning to the set A especially, because here we are not at all representing elements with commas. We are just telling this. Also, let us take another example. Suppose x such that x is an oval. Sorry, grammar mistake. A oval. Plus I oval. Now x is a oval. Here also we gave some rule for that. So this set can be transferred to or converted to the roster form. Like A, what are the alphabets? A, E, I, O, U. So this is the set. Suppose let us say this. No, this is roster form. This is set builder form. That's what the difference. Everything is remaining the same. Here we can uh, use some symbols and write set builder form with rule enclosed between two brackets. Now we coming to JE problems. Let us discuss about type 1. That is, we are going to discuss type-wise problems which are coming in JE mains from past years, also pre-Qs from many pre-Qs. First type that comes in JE main is from sets number of elements. To find number of elements, let us take a question. Let Z be set of all integers and A is equal to xy ordered pair x comma y such that x power 4 minus y power 4 is equal to 175 and x comma y belongs to z, that is they are integers. Then number of elements in A is, this is the question that came in JE mains. Now we'll be solving this. First, to solve this type of questions, let's take the condition. Here the condition is x power 4 minus y power 4 is equal to 174. So let's take that condition. Let's see this question. Let Z be set of all integers. There is a some set Z which contains all integers, and some set A is defined as ordered pair x comma y, where x power 4 minus y power 4 is equal to 175, and also both x and y are integers. Then number of elements in A is dash. The question is asked in this way. To solve, actually we can solve by trial and error method, some by substituting some 2 comma 5 something like that. We'll be checking by trial and error, but it takes a lot of time, which is not at all used in JEE, which is not at all possible in JEE, because there will be a very less time and we should be solving many of the questions in that less time. So for doing this shortcut is there. I'll tell you. Now the shortcut is, first we are given that x power 4 minus y power 4 is equal to 175. We can factorize this as x square plus y square into x square minus y square is equal to 175. Now first thing that we should do is we factorize left hand side. So we write in the simplest possible way. Now in right side you should do the prime factorization, and you should also go to the simplest way. Suppose 175 is 535s and 5 sevens and 7 ones. Now here if we observe, 135 can be written as 5 into 5 into 7. That is 5 square into 7. Now 175 can be written as 5 into 5 into 7. Now let's see, here one term, here one term. First consider this is one term, this is second term, and second consider likewise you should be considering. Okay, first possible way is, let's say uh, x square plus y square is equal to 5 into 7 and x square minus y square is equal to 5. First condition I'm putting here, x square plus y square is equal to 35 and x square minus y square is equal to 5. That applies. By subtracting the, by adding this, y square will be cancelled and 2x square is equal to 40, then x square is equal to 20. Here x square value is 20, but x value will be some root 20, which is some irrational value, but we are given that x comma y belongs to integers, those both are integers, so this is not full way. Then we can take x square plus y square as 5 into 5 one number and 7 leave it as other number, 25, and x square minus y square is equal to 7, which means by adding these again y square will be cancelled. 2x square is equal to 32, x square is equal to 16. Now x will be 4 and y square will be, by substituting in the second equation, y square will be 9 and x square will be 16, then x equal to 4. So we got a possible way, one possible way, and other remaining possible way is 5 into 5 into 7. Let's, there is another possible way. Everybody thinks that there are only two possible ways, that is this and this, but we are also having another possible way, which is by writing into 1. Now 5 into 5 into 7, which is 175. Let's consider x square plus y square is equal to 175 and x square minus y square is equal to 1. Then adding again both, 2x square is equal to 176, then x square is equal to 88. But here also we are unable to get some perfect square, so x will not be integer, so this case is rejected. So there is only one possible way, that is x equal to plus or minus 4 and y is equal to plus or minus 3. So uh, so the only possible way is, we are asked number of elements in A. We got x square is equal to 16 and y square is equal to 9. That implies, which is x equal to plus or minus 4 and y is equal to plus or minus 3. So in A we will be getting 4 minus 4. So number of elements in A is equal to 4. This is how it is solved. There is another Jee Main 2020 recent question, which also some, I'll define the question. I will not write because it's taking a lot of time. Two finite sets having m comma n elements. The number of subsets of first set, that is first set has m number of elements and second set has n number of elements. The number of subsets of first set is 112 more than set, that is number of first set is 112 more than, here it is going, the number of subsets in first set is 112 more than that is 112 more than number of subsets of second set. Now the values of m and n are respectively. We should be finding m and n values. Now we are given that n of a. Suppose let us take first subset as n A and second set as B. Now number of elements of first set is M and second set is N. Now for number of subsets we have a formula that is 2 power n. So number of subsets of first one is 2 power m and second one is 2 power n. Now these difference is 112. So let's first step you should here also we can use trial and error method and solve this equation. But by doing this it takes a lot of time, which everybody does. But we should be clever. We should be doing some to in order to get some good rank and good thing. So take 2 power n common, then it will become 2 power m minus n minus 1, which is equal to, again if you factorize 112 it will be let's get it here, 112, 256, 228, 214, 2 sevens, that's all, 2 into 20, 24, which is 2 power 4 into 7. Here we can equate 2 power n as 2 power 4, so n is becoming 4. Now m minus n, here m minus n, so we should be getting 2 power something minus 1 as 7. 2 power something means 2 power 3, 8 minus 1 will become 7, so m minus n should be 3. We also have n value, m will become 7, so we found out m and n values. So this is how a JEE aspirant solve questions. This is quite easy if you are practicing more and more questions. If you do not practice, just listen, then may be tough. So also one more concept, which is Venn diagrams, which is very much interesting. Let us take two sets. Here outer set, this total is called universal set and it is represented by U. This, let us say this is a set A and this is a set B, then this becomes A intersection B, which is the elements common in both A and B, and A union B refers to this. Let us shade A intersection B. This is called A intersection B, and A union B is called this one. This is A union B, which is the entire part in. This is red is A union B and pink part is A intersection B, and let us say some yellow. This is universal, this is universal set. This is how Venn diagrams are represented. Union of sets means you already understood. So also there are some problems in JEE which are quite simple, but you should keep the mind in that. Like I'll tell you an example. I'll write the question. Let x equal to n such that n belongs to n such that n less than or equal to n less than or equal to 50. If a is equal to n belongs to x such that n is multiple of 2 and b is equal to n belongs to x such that n is multiple of 7, then number of elements in smallest subset of x containing both a and b, both a and b. This is the question. Let's read it. Let x equal to n belongs to n such that 1 is less than or equal to n. That is, n values are from 1 to 50, which includes both 1 and 50, and a is equal to n belongs to x, this element x, such that n is multiple of 2. That means a starts from 2 to to 2 to 50. And B starts from 7 to 49 because it should be less than 50 or equal to 50. Then number of elements in smallest subset of X containing both A and B, which is A union B. Now let's solve the question. X is equal to 1, 2, 3, and so on 50. A is equal to 2, 4, 6, and so on 50. B is equal to 7, 14, 21, 28, 35, 42, 49. Now we should be finding A union B, which is the smallest subset of X containing both A and B. A union B is equal to, sorry, we should be finding number of elements, that is n of A union B. We should be finding. We have a formula which is n of A union B is equal to n of A plus n of B minus n of A intersection B. Now here in the above set n of A contains 25 and n of B 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. It contains 7 elements plus 7 minus both intersection. How many will be there? That is, you should be finding the two multiples in B. Let's find out. 14, 28, 42. These three. That means both common will have 3, which comes out to be 29. So the answer is 29. This is a Jee Main question. See, so thank you friends. This is the basics, minimum basics of sets. Also it has many other questions which involves cardinal number of sets, which are quite interesting. And also there is also type 4 questions which are maximum and minimum values of n of A intersection B, but we are not having that much time, so I was closing the session by this. So thank you. Signing off.